Hello, welcome to Tech Transform. Today we are here to discuss about bucketing concept in Hive. Remember in my last video I have demonstrated about what is internal table, external table and partitioning in Hive. So this is the next level of video where we are going to do bucketing of the tables in Hive. Why bucketing is important? So let's understand with the Apache Hive data model. Let's see, we have a table, then we are storing table into SDFS directory, and after partitioning it is going to create subdirectory like this. But when we bucket into it, it will go and create a bucket of files inside a particular directory. Means creating a partition is creating a subdirectory, and creating a bucketing means you are creating a new files inside that particular SDFS partitioning directory. So why partitioning is so important? Why bucketing is so important? Remember, we already know that partitioning gives you a better performance to write queries and get the result, because it will partition based upon some column value, and it will store only those value in that particular, only those data related to that partition into that partition only. But in bucketing, but let's say you have a data, and you did a partition based upon a certain column, still you will have a lot of subdirectories. So there is a lot of heads on the name nodes to remember all those subdirectories. So again, you're not your query is not faster. So there is again a more Hive is providing a different concept called bucketing. It will bucketed similar value columns in a bucket. Let's say you can create 4 buckets. So let's say you're having column value. The same column value will go in the same bucket list. So it's another way of data organizing technique in Hive, like partitioning. Also, it can decompose larger data set into more manageable ports. And also, when a table is bucketed on a column, then all the records with the same column value will go to same bucket. So let's understand with an example, so it will give you more clarity. So this is the dataset. I will post this link in our in my YouTube description. This is the dataset we are going to use. So let's say we have this dataset related to real estate data. So here we have fields like street, city, zip, state, beds, baths, square feet, type, price. So let's say when we load this data into Hive table, we can create first we load this complete data into a normal Hive table without having partition. Then we'll create partition based upon city. Let's say we are doing with the world population data. Still, after doing partition on based on city, still you have a lot of directory inside that Hive database. So what you will do in order to query your faster, you can bucket this table based upon this street column, and let's say you are assigning 4 bucket inside that partition. So what happened, the same street values will go into same bucket, and different street value will go into different bucket. And again, in bucketing, you can do the bucketing individually to a table, or also it can go along with the partitioning. So once you do the bucketing along with the partitioning, it will give you a more optimized result. So let's see in this in action. Let's open my terminal. So this is the code I have already this is the Hive commands I have already written. I will be executing one by one and defining what's happening. So what we are going to do, we are going to first download this dataset. I have already downloaded and kept inside work datasets real estate.csv. So see how it looks. See, this is how it looks. These all the this streets, city, and all those with comma separated. Let's close this. So it's containing 1000 rows. So we already have dataset. Let's first create our table to hold this input, to hold this real estate dataset. We'll first load this data into input underscore table. For that we are creating one table. So let's enter into the Hive cell. me open a new terminal to show you what is going inside Hadoop directory. Hadoop fs ls home winner work hive data house. Okay, yeah, so Hive started. Let's use data science as our database. Okay, now let's create this table. What we are doing here, we are creating input table to hold our real estate data. Create table, in table name input underscore table. These all the columns I am giving straight city zip, state pets baths, what we just saw in our CSV file. Row format delimited, fields terminated by semicolon. Enter. Yeah, so it's created. This table is created. Now let's move to next step. Next, what we are going to do, I already shown you. This is the link for this dataset. Let's load this data into our newly created table. Shift V. So it's loading data. Now let's quickly check the data. Select star from input underscore table. I'm limiting because it's a lot of record are there, so I'm limiting to 10. See, we got this 10 records. So this data is already there, loaded. Let me clear out. Now next thing is we have to, by default bucketing is off. You have to enable that by doing set hive.enforce.bucketing equal to true, and also by default the dynamic partition mode is strict mode. So, and in order to work with bucketing, we have to run these two commands. Control C. Okay. Control C. Okay. Now what we are going to do, now we are going to create a new table that is called bucket table. We are doing partitioning also, and we are doing bucketing also. So see what we are doing here. We are creating a table, bucket underscore table, with all those columns. Then partitioned by I am doing city based upon city. Then clustered by. Remember, this clustered by command is used for bucketing actually. Clustered by on what column I am bucketing this table? On a street, this on this field I am doing a bucketing into 4 buckets. So it will be keeping all those same street values, and it will be by default it is Hive is assigning a hash functions, and will be keep moving this same hash functions file into 4 buckets. And remember, the column which you are selecting here in clustered by, it should be present here, and the column you are doing partition by, it should not be inside your table, inside your table column. Okay, so this should be you should not keep this city partitioned by column in your main table, and your clustered by column should be coming from this column sets. So let's run this. Okay, so it's created. Now quickly check its schema. Describe bucket underscore table. See, we have all these columns, and it is also saying me it is going to partition based upon city. Okay. Now let's move to our document. So we have just created a bucket table, we have partitioned, and we have clustered also into 4 buckets. Now let's insert into this bucket underscore table using our input underscore table, which we last created and loaded with the data. This one. So let's copy this command. C. Come here. Control Shift V. Okay. So it's launching a map reduce, it's doing reducing and all those, because bucketing concept is like it's going to bucket same column value data into one bucket. So that's the concept called reducing. So it will be do lot of reduce in order to categorize all those data to a four buckets. And I want to show you what's happening inside SDFS directory also. Let's move inside datasets datascience.db. So this is our in let's check the input table. You can see the real estate.csv is loaded here inside input table, the raw data. Now let's check our, so let's see if it's completed or not. Yeah, it's completed. It took for 53.45 seconds and it loaded all the data. So see how it's look like. Go inside bucket underscore table. Yeah, see what happened. So we did a partition based upon city. So this real estate dataset contains 39 unique city. So based upon city, it's created different subdirectories. So whatever you are seeing here, this is one directory. This is one directory. So partitioning is related to creating one directory, creating a different directory, and bucketing is creating a file inside a directory. So in every first what Hive did, it categorized the data based upon city and created a different subdirectory based upon different city. Now based up now whatever data comes under this antelope city, based upon different similar state, because we did partition on street column. You can see we did partition on street column. So what it will do, it will go and create four buckets, and it is going to assign using hashing function. It will go and assign some street values to some buckets. Means it is not going to repeat that particular street value into different buckets. So it will already know and creating a hashing function inside that, and once you query over that, it will give you result faster. So let's go inside any one directory. So this is what Control Shift C. Let's go inside. Okay, so it's running. See, for four buckets, what it did, it create four partition. It get four files. So this is what the concept of bucketing. Let's quickly check what is inside this file by coming to browser. Let's run our Hadoop utility from browser. Let's go inside utility, browser file system. So remember our path work inside Hive. This is warehouse. This is the actual folder. Then our database datascience.db. Then this is our normal table, input underscore table, the raw table having one file, and see bucket underscore table. These are the again directory. Okay, so this created 39 directory inside the bucket underscore table. Now let's go inside this subdirectory. So these are the files. So see, it's bucketed all the data on the street value. Four bucketing it created. Let's quickly check this data. Download, open, let's close this. So see, it's bucketed data based upon the street value. So these streets these street value you're not going to see in other bucket. Other buckets will having different streets value. So that's how it's making the query faster. So sometimes you don't go with only partitioning, you won't get the actual performance with the query result. In order to optimize that, you should also do bucketing. So that's all for this video. Thanks for watching. Have a good day. Bye.